This is polynomial and rational inequalities, section 3.6. Now solving polynomial inequalities. First step is to get everything on the left side, 0 on the right side. Problems will look like this. You'll have a polynomial, and your goal is to get everything on the left side, 0 on the right side. And a lot of the problems are already in that form. Step 2, set the left side equal to 0 and solve. And these are going to give us something called our critical values. Means there's something potentially happening there. Now, after you have your critical values, then you want to use the x-axis in critical values. Using the x-axis for critical values, build a table of intervals. Then use the graph to figure out your answer. If you have a greater than or equal to, your answer is where the graph is above the x-axis. If you have a less than or equal to, your answer is where the graph is below the x-axis. If you got a less than or greater than, then remember the less than or greater than means it does not include a number. So we're going to use parentheses. Less than or equal to or greater than equal to. Remember the equal to part means it includes it, so that's where we use brackets. So let's take a look at our first problem. Got it. X squared plus 4x minus 5 is less than 0. Steps I'm going to be referring to are these just over here. So step 1, get everything on the left side, 0 on the right side. That's done. Step 2, Set the left side equal to 0 and solve. So x squared plus 4x minus 5 equal to 0. Now this will factor using the PSD. Factors as x plus 5 times x minus 1. Zero factor property says you set each factor equal to 0 and solve. And you get x equals negative 5 and x equals positive 1. And those are our critical values where something potentially is happening. Step 3, using the x-axis. Here would be the x-axis. The critical values. Here's negative 5. Here's positive 1. Using the x-axis and critical values, build a table of intervals. What we mean by that is these separate this portion right here into intervals. Clear over here is negative infinity, clear over here is positive infinity. This first interval is negative infinity to negative 5. The second one is negative 5 to 1, and this last one is 1 to positive infinity. It says then use the graph to figure out your answer. I brought my, I didn't bring my flash drive, so guess I'll have to show you the graph in a different way. But you plug it in your TI3, TI4. In your case, you press your y equals, you press clear on y1, and then you put in your x squared plus 4x minus 5. Now what you're going to notice is that your graph crosses at negative 5 and positive 1, which corresponds to our critical values. So we want to sketch our graph on here. Like that. Doesn't have to be precise because we're not caring what the graph really looks like. All we're trying to identify is above or below the x-axis. Now our problem here was a less than. So that less than there tells us that our answer is where the graph is below the x-axis. Well, it's below the x-axis in this interval right here. Now, if it's below in part of the interval, it's below in all of the interval. So you don't have to sit there and question that, even though it's pretty obvious that's all below. So our answer is going to be negative 5 to positive 1. Now, specifically, we had a less than here. And our instructions say, for a less than, we're going to use parentheses, which means I'll put parentheses around them like this. And that's interval notation. When we're solving polynomial inequalities, you won't just have like one answer. You'll have a range of answers. There's actually an infinite number of values between negative 5 and 1, not including negative 5. Questions on that? Okay, let's take a look at number 2. (15x squared) plus x minus 2 is greater than or equal to 0. Step 1. Get everything on left side, 0 on right side. That's done. Step 2. Set the left side equal to 0 and solve. Now this does not too early in the morning. What is that factor? I don't think it matters. Okay. So we'll use a quadratic formula. A will be 15. B will be 1. C will be negative 2. Remember, A is whatever's in front of your x squared. B is whatever's in front of your x. And C is your constant term, the number at the end. And our quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. It does factor. Quadratic formula would have gave that to us, but 3x minus 1 and 5x plus 2. So zero factor property. Set each one of those equal to 0. Here I get 3x equals 1, x equals 1/3. And here take negative 2 over, divide both sides by 5, and you get negative 2/5. So step 3, build a table of intervals. You want your smallest one first. So we'll put the negative over here and a positive over here. Remember, this splits it up into intervals. Clear over here is negative infinity. Clear over here is positive infinity. Now, if I were to graph this, I know it opens up. Understanding about what a polynomial happens with the signs and everything just simplifies it. Because an x squared, remember, specifically it's a polynomial, but it's also a parabola. You got a positive number in front of it, it opens up, doesn't it? And I could graph it if I want, but since I know that, and I know what the critical values are, then I know it's coming down here, it's crossing here, crossing there, it looks like that. Now, when you look at the graph, you'll think, boy, that didn't look like that. The graph looks something like, I don't know, something like that. Doesn't matter, because all we're trying to do is identify the above and below. So it doesn't have to be precise. Now, this problem was a greater than or equal to. So greater than or equal to answers where the graph is above the x-axis. It's above over here, and it's above over here. Now this interval is negative infinity to negative 2/5. This interval is 1/3 to positive infinity. Now greater than or equal to, we said we're going to use brackets. So put a bracket on -2/5, bracket on 1/3. Now, infinities always have parentheses on them. And then if you got two or more intervals, you connect them with union symbols. And that'll be your answer. Take a look at this one. X squared is less than or equal to 3x plus 3. Take those over to the left side, and we get x squared minus 3x minus 3 is less than or equal to 0. Step 1, you have to get everything on the left side 0 on the right side. Now this one does not factor. I can see this one. So step 2, when we set this equal to 0 and solve, we're going to have to use quadratic formula. A is whatever's in front of your x squared, B is whatever's in front of your x, and C is your number at the end. So we got negative b plus or minus square root of b squared minus 4ac all over 2a. We're going to have negative 3 plus or minus square root of negative 3 squared minus 4 times a, which is 1, times c, which is negative 3, all over 2a. Negative gives me a positive 3, plus or minus. Negative 3 squared is 9. Negative 4 times 1 is negative 4 times the negative 3 gives me a positive 12 over 2 times 1, which is 2. So that gives us 3 plus or minus square root of 21 over 2. Now, I don't know much about that, but I do know that 3 minus the square root of 21 over 2 is less than 3 plus square root of 21 over 2. You could also plug those in your calculator if you're not seeing that. That would show you that fact. Now, if I graph this, where you'd want to graph it at is the part where you have everything over on the left side. So this is what I'd want to graph. Since I know what an x squared does, it's a U-shaped graph of some sort, and a positive number in front of it, the invisible 1 there, that means the graph opens up. Which means my graph looks like that. This problem was a less than or equal to. Less than or equal to, your answer is the graph is below the x-axis. Below right here. So our answer, 3 minus square root of 21 over 2 to 3 plus square root of 21 over 2. Now it's a less than or equal to. So less than or equal to. And less than or equal to tells us we're going to use brackets. So that'd be our answer. Grab a drink. Questions on any of these? Okay, this next one is not quadratic. Got x to the third, 7x squared minus 4x minus 28 is less than 0. Just still the same steps. Step 1, get everything over on the left side, 0 on the right side. That's done. Step 2, set the left side equal to 0 and solve it. Well, this one I can factor by grouping. So group first two terms together, group last two terms together. First two terms have an x squared, and that gives us x plus 7. Second group has a negative 4 in common, and that gives us x plus 7. Now they both have an x plus 7 in common, so I'll factor that out, and that gives us x squared minus 4. The x squared minus 4 is the difference of two squares. So this factors as x plus 7 times x plus 2 times x minus 2. Zero factor property, get 0 one side, you factor the other side, set each factor equal to 0. So x plus 7 equal to 0, x plus 2 equals 0, x minus 2 equals 0. And we get negative 7, negative 2, and positive 2. So our smallest value is negative 7. Next one is negative 2, and next one's a positive 2. Remember these split them up in intervals. Clear over here's negative infinity, clear over here's positive infinity. Again, knowing what happens with the leading coefficient test and all that, I know my graph is going to come up like this. And go up like that. But if I had trouble seeing that, you just graph it. And you see it. Again, the fact I can't see the top or bottom does not matter. Because all we're trying to see where it's above and below anyway. Now this problem was a less than. Less than tells us our answer is where the graph is below the x-axis. It's below in this interval, and it's below in this interval. So this will be negative infinity to negative 7. This will be negative 2 to positive 2. Now our problem, specifically, is a less than. Less than means use parentheses. Parentheses, parentheses, parentheses. Infinities always have parentheses and then union symbol in between them. And that'll be our answer. One more. This is an oddball case. This one example does not indicate all the different oddball cases you run across. Okay, step 1, get everything on the left side, 0 on the right side. That's done. Step 2, take the left side, set it equal to 0, and solve it. This factors as x minus 2 times x minus 2 using the PST method, or x minus 2 squared. I then set the factor equal to 0, x minus 2 equals 0, and I get x equals positive 2. Now, two ways you could do this. I know it opens up because it's a positive x squared. Since there's a 2 here, the multiplicity is 2, that tells me it touches. Opens up and touches would tell me it's coming down, touching at this point, and going back up. Or you could just graph it. Now it's a less than. Less than, your answer is the graph is below the x-axis. There's nowhere it's below the x-axis. So the answer is no solution. Okay, let's take a look at rational inequalities now. Rational means a single fraction. This is an example of a rational inequality. Got an inequality symbol, and you got a single fraction, specifically with variables in the denominator. So solving rational inequalities. Step 1, get everything on the left side, numbers on the right side. Step 2, if necessary, rewrite as a single fraction. It might already be a single fraction, but that's what rational means. So you can't be solving rational inequalities unless it's actually a rational inequality. I don't think I want numbers on the right side. Everything left side 0 on the right side. Sorry about that. I didn't sleep very good last night. Hurt this morning. There are no numbers in these. I mean, technically I wouldn't be incorrect, but it doesn't matter. Okay, if necessary, rewrite as a single fraction. Step 3, factor the top, factor the bottom. Then set each factor equal to 0. And solve. And these would be your critical values. And then step 4, using the x-axis, critical values, build a table of intervals, then use a graph to figure out your answer. Greater than or greater than equal to, answers where the graph is above the x-axis. Less than or less than or equal to, the answer is where the graph is below the x-axis. If you got a less than or greater than, is parentheses. If you got less than or equal to or greater than equal to, is brackets. So those steps are the same as what we saw with the first ones. So let's take a look at this one. Solve each rational inequality, graph the solution set in a real number line, express each solution set in interval notation. Step 1, get everything on the left side, 0 on the right side. That's done. Step 2, if necessary, rewrite as a single fraction. It's done. Step 3, factor the top, factor the bottom. X plus 3, x minus 1, I can't really factor. Then set each factor equal to 0 and solve. So I'm going to set x plus 3 equals 0 and x minus 1 equals 0, which gives us negative 3 and positive 1. Okay. Step 4, using the x-axis and the critical values, build a table of intervals. Remembering, clear over here is negative infinity, clear over here is positive infinity. Then use the graph to figure out your answer. Now, at the point where you want to graph this is where you got 0 on the right side and you got a single fraction over here, which is the way this was to begin with. So that's what we want to graph. Remember, in graphing these, the key to it is put parentheses around the top, parentheses around the bottom. So we got x plus 3 divided by x minus 1. Now, again, where the critical values are is where something important is potentially happening. Our first critical value member was -3. If I look to the left of -3, here's -3. To the left of it, it's above the x-axis. So I'm going to put a little tick mark here to indicate above the x-axis. You don't have to actually write the graph down because all we care about is above and below. Now between -3 and 1, here's -3 and here's 1. I see the graph is below here. Well, if it's below in part of it, it's below in all of it. So that's below. And to the right, a +1. +1's right here. To the right of it, it's obvious it's above the x-axis. So I'll put a little mark there. Now our problem was a greater than. So greater than or greater than equal to answers where the graph is above the x-axis. It's above here, and it's above here. So my intervals for my answers are -∞ to -3. This one will be 1, +∞. Now our problem was a greater than. Greater than tells us the answer is where the graph is above the x-axis, and it's going to be parentheses. So I'm going to put parentheses on these. Now infinities always have parentheses, so you're fine there. If you got two or more intervals, you put a union symbol between them. And that'll be our answer. Questions on that one? Let's take this one. Same instructions. So x minus 4, x plus 3, or x minus 1, less than or equal to 0. Step 1, get everything on the left side, 0 on the right side. It's done. Step 2, get a single fraction. That's done. Step 3, factor the top, factor the bottom. They're factors as much as they can be, so that's done. Then set each factor equal to 0. So I'll set x minus 4 equal to 0, x plus 3 equals 0, and x minus 1 equals 0. And I get x equals 4, x equals -3, and x equals +1. And those are our critical values. When I range them on my x-axis from smallest to largest, so -3 goes first, then 1, and then 4. Again, these split them up into intervals. Clear over here is -∞, clear over here is +∞. Key to it is put parentheses on top, parentheses on the bottom. Okay, so this is what our graph looks like. There's our first critical value here, -3. So here at -3 to the left of it, I see it's below. Now between -3 and 1, here's -3 and here's 1. I see in part of it's above. If it's above in part of it, it's above in all of it. From 1 to 4. Here's 1, here's 4. I see it's below. So below. And from 4 on, I see my graph is above. Now we got a less than or equal to. That tells us two things. Less than or equal to, we're looking for where the graph is below the x-axis, which is right here and right here. Also, less than or equal to, besides telling us below, it tells us to use brackets. Now this interval here is -infinity and -3. This interval is 1 to 4. Infinities always have parentheses on them. I said use brackets, so it'll be a bracket there, parentheses, and union symbol. Now I changed patterns here. I said brackets, but then I put parentheses on the 1. Notice where the 1 came from. Came from the denominator. If I were to plug x equals 1 back in, and specifically in denominator, I'd have 1 minus 1, which is 0. You can't have division by 0. So as a note goes along with this. So note, any critical value comes from the denominator, always has parentheses. Is that it can never include that value. Okay, that's a problem here. X over x minus 3 greater than or equal to. Step 1. What's wrong? This one does have a number. Step 1, get everything on the left side, 0 on the right side. So I take 2, move it over. Take anything across your inequality, sign changes, just like before. Step 2, get a single fraction over here. So this is like the mixed number rule. I'm going to take -2 times x minus 3, then add the x. So -2 times the denominator, and add the numerator. And denominator stays as is. -2 times x is -2x plus x gives me a -x. -2 times -3 is a +6. And we got our rational inequality. Step 3, back to the top, back to the bottom. I can factor a -1 out of the top, but it doesn't do me any good. So I'm going to jump directly to setting those equal to 0. Negative x plus 6 equals 0, and x minus 3 equals 0. Now here I'm going to take negative x over, so I get x equals 6. Here I take negative 3 over, and I get x equals 3. Now I'm going to go ahead and get the graph while it's just showing. Again, the key to graphing that is put parentheses around the top, parentheses around the bottom. Okay. Here I got 3, and here I got 6. And they'll split them up in intervals. Clear over here is negative infinity, clear over here is positive infinity. The left of the 3. 3 is right here to the left of it, it's below. Between 3 and 6. Here's 3, and here's 6, it's above. And greater than 6. Here's 6, and I see it's below. Now our problem was a greater than or equal to. Greater than or equal to is above. So this will be my answer. From 3 to 6. Greater than or equal to, besides telling us above, tells us to use brackets. So we'll put a bracket on the 6, and we'll put a parentheses on the 3. Again, remember, if any critical value comes from your denominator, it always has to have a parentheses on it. So it cannot include the 3. Questions on that? Well, we're ahead of the material, so I think we're going to stop there. I'll leave the rest of the time. If you're struggling with anything, you stick around and you can ask any questions you have. Next time we'll finish chapter 3, so we'll be ready for the chapter 3 test, and then we'll be going into 4.1. 3.7 and 4.1 are fairly small, so we'll cover both those on Wednesday. Still be more or less a week ahead. Not so disturbing, except for that a lot of these are very quick sections. So I don't know if I can stretch them out over 3 hours like 6.3 and 6.4. If I show it by hand, I definitely can.